Hello Water Managers, I'm Fauwaz Hanbali with the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to cover the SWMS overview presentation. In this part of the presentation, I'll give an orientation on the core water management system, SWMS. SWMS is a decision support tool for water managers in the Corps to execute the water management mission and meet legislative requirements. It's an automated information system, AIS, that is used to collect, process, and store real-time data. SWMS also includes a suite of modeling software used for real-time forecast simulations of reservoir systems. SWMS has a centralized database that ingests real-time data from satellite and radio telemetry and from a variety of web services. The SWMS Real-Time Simulation RTS suite of software provides water managers with access to the database and simulation tools. With the RTS software, water managers can analyze hydrologic and hydraulic processes to help determine reservoir operations and share that information with partner agencies and the public. In this course, we'll primarily focus on the modeling components of SWMS and the use of the RTS suite of hydrometeorological and hydraulic software. But since simulation modeling is dependent on the reliable availability and access to real-time data, we'll touch on the data side of SWMS a little bit here. SWMS real-time data acquisition processes run on a remote server. These processes are automated to collect real-time data from gauging stations and meteorological products from web services. These processes decode the transmitted data into usable formats. Data validation and corrections are also performed so that good data can be used in the RTS software for monitoring watershed conditions and executing forecast simulations. The vast majority of stream gauge data acquired in SWMS is available from the USGS web services. Typically, that includes observed stream flows and stages, stored as time series data in the SWMS database. Forecast stream flows and stages come from the National Weather Service River Forecast Centers, and a variety of National Weather Service centers provide gridded meteorological products including quantitative precipitation estimates, QPEs, quantitative precipitation forecasts, QPFs, and temperature and snow products as well. The primary interface for SWMS is HEC-RTS. It provides access to real-time and forecast data. HEC-RTS also integrates a suite of modeling software with a common display of watershed and river system elements. The HEC-RTS suite of models consists of HEC-MetVue for meteorological data processing and visualization, HEC-HMS for hydrologic simulation, HEC-ResSim for reservoir system simulation, HEC-RAS for hydraulic simulation, and HEC-FIA for impact analysis, where the potential consequences of stream flow and stage forecasts are assessed. Starting with HEC-MetVue, meteorological scenarios are prepared by processing and combining observed and forecast data sets to provide a single input to the hydrologic model. Typically, processed gridded data includes precipitation, temperature, and snow. HEC-MetVue visualization capabilities help with the review and inspection of individual data sets. HEC-MetVue also allows for applying data corrections if necessary and allows for applying data adjustments to generate what-if scenario simulations. Next, the hydrologic modeling system, HEC-HMS, takes input meteorological data and is used to compute rainfall and snowmelt runoff. Gridded runoff modeling is a primary SWMS application of HEC-HMS, and HEC-HMS is used to produce reservoir inflows and local flows downstream of reservoirs as inputs to reservoir operations and hydraulics models. The reservoir system simulation component of SWMS is HEC-ResSim. HEC-ResSim takes input flow data, reservoir operating rules, and user-specified releases to simulate reservoir system operations. The local flows from HEC-HMS and reservoir releases from HEC-ResSim feed the hydraulics model, HEC-RAS. And HEC-RAS, the river analysis system software, is used in SWMS to estimate river stages and potential flood inundation based on observed and forecast weather event scenarios. HEC-RAS produces stage hydrographs, water surface profiles, and inundation grids, which help inform water managers and emergency managers about potential flooding to prepare for and mitigate. Finally, the flood impact analysis HEC-FIA software is used in SWMS to identify consequences from a flood event. HEC-FIA models contain structural and agricultural inventories with stage damage cost relationships data. With the additional input of forecast stage data from HEC-RAS, HEC-FIA estimates the potential threat to life and damage costs for structures in agricultural areas. HEC-FIA also provides impact response actions for water managers to plan for during a real-time event. Finally, the full suite of SWMS models, including HEC-FIA, are also used on an annual basis to conduct flood damages reduced FDR analyses for all flooding events that transpire in a year. These analyses estimate the cumulative benefits of core reservoir operations in mitigating flood damage costs based on the simulation of regulated conditions versus unregulated conditions. To sum up, SWMS modeling relies on real-time and forecast hydrometeorological data like rain, temperature, snow, and stream flows, which are acquired, validated, and stored in a database in an automated fashion. The real-time simulation software, HEC-RTS, is the primary interface for SWMS users to access data and the integrated suite of HEC models, MetVue, HMS, ResSim, RAS, and FIA, to evaluate forecast scenarios and inform reservoir system operating decisions. This is the end of this part of the presentation. If you have any questions about our software, need some help, or are looking for additional training, please check out the links below, and thank you for your time.